Well, hello, good morning. It's December 15th. The Ides of December are upon us. Oh my gosh. And here's this radio, which surprised me yesterday by actually working. I really didn't expect this radio to work, but it does. Now the question is, I think, how well does it work? Considering the surprising fact that it works in the condition that it's in, actually it's not that surprising. I have lots of radios that in fact work right out of the box, so to speak. They don't work well. They work. There's the question right there. Does this radio work well? Does it work on all bands? Is it sensitive on all bands? Stuff like that. Maybe we can pursue that today. Try to find out the state of the radio before monkeying around with it and changing parts. And for me personally, I really like it when a radio works, even if it works very poorly at the start. Even if all it amounts to is you touch the antenna and some noise comes out the speaker when you do that. Even that's better than the dead radio. Working on a dead radio is, well, there's a risk there that you'll do something that actually increases the deadness, but you can't tell that you've done that. And so you could work in a number of errors, I certainly could, on a dead radio waiting for it to come to life. And of course you could correct the original problem, but on the way having made more of your own. So that's why I like it when radios work even to any degree. And this one's working really quite well. I was really kind of floored by it. So to test this out, I think the best way is to feed in controlled signals. Control the frequency and the strength of the signal rather than use an antenna, which is rather hit and miss. Now I think yesterday there was a big solar explosion, caused an X-ray blackout, but only for about a half an hour. I don't know if it affected North America or not, but the point is things go up and down when it comes to ordinary shortwave signals, and you can't really rely on them for doing too much testing, whereas this is going to work a lot better. Let's disconnect it just to start. Okay, I'll turn this down. I'm familiar enough with this signal generator that I can tell as I feed the signal into the radio whether the radio is sensitive or not based on its response and the settings on there. Okay. Well, so this came without any knobs. Is this going to work? Just happen to have a knob laying there. Yeah, it'll do the trick. So I think this setting is phono and this setting is broadcast band. From there, the radio may hop around in these bands, not necessarily following up straight through. Don't know, but we can find out. We will find out. So we have it set to AM. Volume is up just a bit. Tone is at the bottom because it has the on-off switch. We're going to switch it on, but there's no power yet. Now there's going to be power. It'd be handy if one of these lights worked because it would remind me when the radio is switched on. I can see the rectifier tube heating up. So we got all of 73 volts. That's not much. It's really not enough. Radio's trying to draw a fair bit of current and the dim bulbs are restricting it. So, okay, so we're going to just go right up to full power from here. Yes, the dirty volume control. Maybe we got to deal with that right away. Because it's going to... Yeah, okay. Power off. We're going to deal with the noisy volume control. Okay, so what I use is WD-40, and this upsets people. Does it really? And I'm just going to spray it right into the works here. I often do this with the radio operating, so you can hear the effect. But I know from experience this really works. Okay, can we leave the radio on its side? Is there any reason to do that? It'd be trouble reading the dial. I'll have to turn my head sideways. Okay, once again, here we go. I boldly put it on, straight on, full power. So bold. Now the last couple of months I've experienced something I've never had happen in years and years and years of doing this, and that is frying up capacitors. I've had 2 radios with frying capacitors in them. So this guy's going to be on for a while today. If something like that is potentially happening in here, I should pay attention. How come I didn't clean that tube there? Look at that filthy tube. So I'm giving the radio a good chance to warm up before we start. Oh. He's a very dirty guy. That's pretty good now. It's full volume, but there's really no antenna on it. So I don't think that's a concern. For some reason I was cleaning this tube. Where's the words? I don't see the words. I want to wash the number off of it. Okay, looks a little better. How did I miss that guy? Now, there's another one in here. You know what? It's the original ones that are dirty. Tune around a bit, not with this one. Did I spray this already? Hey, bring back the WD-40. I didn't think I did anything to this radio, did I? So this sound is probably from the pieces right in here. Let me get a brush here. Fairly stiff. Wow, this is the one I'm going to have to use here. So there are sliding ground contacts in these capacitors that get dirty. And I don't know, can you see them with the, let me get a little closer here. So if you look, I'll point with this. You can see a piece of bent metal here. There's 2 pieces here and 2 here. Very hard to see in the video. Those are spring-loaded pieces of copper intending on shorting the frame to the rotor at the contact point right in there. You might not think WD-40s, how can that possibly clean stuff up, but it seems to do the job. Does not seem to do the job. Now, is that a station? Oh, it is. It's a thing. That's not dirt. That's a thing. What thing it is, I don't know. What about the one down here? See, that one's dirt. How come you're not cleaning up? It's worth noting the the tuning capacitor is up on grommets here. It's mounted up on grommets. That could be just to allow movement in it a little bit. I think that's the case because I can see big ground straps down here. Okay, let's see if we can figure out just what it is exactly. So we're going to put it right in the sensitive zone. If you can call that the sensitive zone. We hear a thing there. most likely spot for this noise to be generated. Let's try a little bit of another cleaner here. So WD-40's big brother, dioxide. I am not related, like different companies, I'm sure. Big Brother's just don't take me seriously. Nobody ever take me seriously. Serious. I'm serious about that. I find that a lot of gas comes out of this. Not much fluid. Maybe that's as good as we're going to get today. Funny that it's so distinctly in one spot. Okay, I'm turn the radio down. Can we hear this coming right out of here? What is that? Sounds almost like a capacitor is rubbing. Oh, there is a plate here which has been... Okay, so if you look, not a, I shouldn't have reacted that way. See, this plate is bent out and this plate is bent out a bit. That's probably been done on purpose. You see this plate? See how it's bent in? That's not on purpose. That's an accident. I'm going to bend it out. Because I think it was making contact. Just a brush contact. Using the precise thumbnail technique here. Okay, let's see. What does it do now? No. Is there another spot? This one looks a little pinched in too. Okay, well, we can find out if I can touch those plates with it in the sensitive spot. And listen for the noise. Hard to get in there. I really can't get at it. It's, you know, it's up inside. A little distracted from what I intended on doing today, but you know, that's par for the course here. Let's see. Where'd the noise go? It's there. Okay, camera, come on. Autofocus has a hard time with patterns. If there's a pattern in its view, it seems to have a very hard time with it. So I'm just looking at the spacing. It all looks pretty good. I'm looking at the upper part first, and then the lower part. So there's one there on the left that's a little close. Tube in the way. This radio's operating, Jim. Don't forget that. I can easily forget that. So there's nothing there. So there's one that's a little close on here. That's not close enough to worry about. Don't see it. We're not going to worry about it anymore because I've reduced it anyway. Don't worry about it. The problem will probably be there for me to consider later. Okay, so we're on the broadcast band. We're going to tune the radio. Oh yeah, no, not. Oh, there's no pointer. There's no point. There's no point. There's no pointer. There's no point. Right. I can't. Hello, just waking up there. So there's no scale or anything on the back. So what we'll do is, well, let's see. That should be 530 or so. Let's just see what happens here. Oh, it's almost set to the IF frequency. Well, we'll do that in a bit. Let's just see if this thing will work. Oh, don't, no, come on, counter, don't do it now. Darn you. So, okay, hook this up. It's interesting. So let me turn down the volume. The IF frequency in this radio is 456. My counter is usually one number low in this range, so this is probably 455 right now. So I'm going to just tune a little bit here. Right on the money. It would appear to me. Very good. Okay, so that's a quick check of the IF frequency and or IF tuning, and it seems to be really good. Now we're at the low end of the AM band, so we should pick up 530 or something like that. Very good. So we're right in the, may not be exactly correct, but certainly close. Now we'll wheel up to the other end of the dial. That should be 16 or 1700. Oh, the dial's over here. No, the dial's right in front of me, for crying out loud. 15. Looks like really 16 is the top, but let's, wow, she's gone again. 16, so to get to 16, I have to go here, and we've got to, now there is a scale on my machine there, but it's pretty far away for me to see it. 2.2. Okay, let's read the scale. I'll use my other camera here. $16. Well, seems to be fine. Now, what about signal strength? So I have the signal generator feeding straight into the antenna. Let's calibrate the machine here. It's just about calibrated. So that is that's a medium sort of signal, signal you would get from a local station with a decent antenna of some sort. This would be faint. I'll turn it up. So you can still get lots of volume out of the radio. This would be a faint signal. Very good. Okay, so and it's a good thing to check the sensitivity on the broadcast band. That's actually a good choice. Now we're going to go one band up into shortwave. There we are. So we could be on this band. Well, we could be on any one of these bands, but we'll go hunting. Between 2.5 and 7. My signal generator. Come on, man. There we are. There we are. There's the actual frequency I was putting in. Or did I move this? It was, no, it's where it was. So that's when I had the radio where at the top of its range it was picking up 1560, a little low. But the broadcast band went to 1600 back then, now it goes to 1700. So we want to go up to 2.5. Let's go here. I'm going to go in the middle of the band. Middle of the band is roughly 3.5 megahertz. 3.5. So that's about 3.5. That's got to be it. Very good. That's very good. Okay, now shortwave should be a little more sensitive. Okay, that's about half volume there. And a good receiver will receive this. Check the calibration. Check the calibration. Make sure I got something consistent going on here. You can still hear it. A little bit of tuning. So sensitivity on this band is right up there. Right up there. This is a great radio. Now, what I want to go next band up. Now, I could be wrong about this. You know, I could be on one band, stick in a frequency, and hear it when I shouldn't hear it at all. That it could happen. So I could be fooled by doing this. So we're up one more band. If we went up the next band, we're around 9.5. 9.5 is right on the band change here. Darn it. Okay, so I'm gonna, oh yeah, put up the power here. So I'm gonna tune the radio to see if I can find it. Well, there it is, but it sure seems to be off. 9557. 9557 is in the middle. Well, capacitor's not in the middle, but it's a little off, but it's there. And sensitivity. Sensitivity, wonderful. Okay, next band. Okay, if we are continuing up, then we're around 11.8 here. 11.8. Look at that. Wow, this radio's in really good shape. I'm really stunned. Again, we're not really in the middle, but it doesn't mean the capacitor should be in the middle to be in the middle here necessarily. Well, that's great. Let's go another band. So now we're on the 19 meter band. The middle is roughly 15, 15.2. 15.2. Now it's much quieter this time. Is that because of something I did? That's full volume. And tuning. These band spread radios where there's really quite a small frequency range from here to here. They're wonderful to tune. The problem is this ends at 15,350, but the band today actually goes up to 15,700, goes way up to here, and there's stuff up there. So this radio can't hear everything that's there to be heard. Now the next band up is different. It's not spread so much. It goes from 17 megahertz to 22, and that's a range of 5 megahertz through there. This is a range of a couple of 300 kilohertz here. 5 megahertz means the tuning is much sharper here. More difficult. Okay, let's go up there. Okay, that's the top, about 18.5 in the middle. Sure is quiet. Didn't think they're awfully quiet. That's full volume. It's very quiet. 18.5. 18.5. So you see I'm picking it up in two places. This is basically 19 megahertz. $18.08. So if you take 455 and double it, you get 910, something like that. If you add 910 to this number, you get 19 megahertz. So what we're picking up here is the image frequency. One of these two signals is the image. And these radios are bad at snuffing out an image. They use a IF, which is too small in frequency. 455 kilohertz not enough to spread the image so far away from the target that you can't hear it. Even if there's a station there, you won't be able to hear it. It's suppressed by other tuning factors in the radio. But with the IF so close, you know, here, if you like, if you subtract the IF frequency, you're just coming down like this much or something. The front end tuning, you can't even tell the difference between the two of them. They are about the same level. If the image was way down here, it would be suppressed by the tuning. Something like that's going on. So there's probably instructions in the alignment instructions on exactly how to avoid tuning this radio up on the image by accident. And as far as I know, there's no alignment instructions available for this radio. That's what I've discovered so far. There's other ways to figure it out, and most importantly, in today's world, with an SDR, you can visually see the frequency of the local oscillator. You can sort a lot of things out that way, which I'm sure we'll be doing. Well, turns out this radio works really well. And it also turns out I have to go to the grocery store to pick up some groceries. So my time is up here. So that'll give you some things to think about. You know what we never looked at? We never looked at this, the magic eye. Turn it back on. Is there any magic in the magic eye? These radios, the magic eye is right in the middle. It's hidden back here. In fact, you never even realize it's there unless it comes on. And I don't think it's coming on. Why did I turn this on? Something funny happening here. Oh, look at this. We're only at 99 volts because I turned this down the other day. Not that it's going to make any difference. That's a little better. Now, is the magic eye glowing at all? I don't see anything at all from it. You can hardly even see it behind there. It's right in behind here. You know, there's the bulb there. There's the bulb. Well, no surprise there. Fortunately, I have some magic eyes. I can stick one in there when the time comes. Very good. Power off. Power off. Why didn't we hear anything from that? I don't know. Who knows? I don't know. Because the radio wasn't even on. The radio wasn't even on. Turn the radio on. See, I gotta change these lights. That's better. Now what do we see? Do we see anything down here? Pull off some lights. Darken things down. What's all that crackling? No. On the magic eye, the answer is no. What are you seeing? Oh, you're seeing a reflection on the screen of the... You're seeing a reflection of all that stuff on there. Okay. How about just turn on the other light and that'll solve that problem. The noise that came and went. Don't know what it was. Did you even hear it? There was some crackling in there. Okay. Enough fooling around for today. That's enough. We'll switch it off. No surprise that the eye is worn out. I think it'd be very surprising to find a radio like this with a bright eye. Sometimes the eye is still visible, but it's really... Oh. Tripod failure. Okay, after that, tripod failure, that's the end of the video. So thanks a lot for watching. Tomorrow, what am I going to do to this radio? What do I need to do to it? Should I do anything to it? At the very least, examine the parts underneath and look for any that appear to need to be replaced. But wow, the radio's working really well as it is. It's almost disappointing in a way. Man alive. Thanks a lot for watching.